Hello everyone, welcome to High Voltage YouTube channel. Today we are going to see concept plus objective bits on lap and wave winding of DC machines. DC machines part 2. Basically, armature windings are two types. First one is the lap winding, second one is the wave winding. Now we will see some important points one by one by comparison table. The table is basis for comparison lap winding, wave winding. First one, connection and define. The connection of the lap winding is the armature coil finishing end is connected to the nearby adjacent segment on the commutator, whereas the connection of wave winding is the armature coil finishing end is connected to commutator at some distance apart. So in lap winding, this is the finishing end and this is the starting end connected nearby adjacent segments on the commutator, whereas in wave winding, this is the finishing end and this is the starting end connected to the commutator at some distance apart. In lap winding, coil turns overlaps one another and hence it is called the lap winding. In wave winding, the coils are connected in the wave shape and hence it is called the wave winding. So next one is the parallel path and brushes. A is equal to P is equal to brushes, where A is the number of parallel paths and P is the number of poles. Whereas in wave winding, A is equal to 2 and brushes also 2. So next one is the armature current. In lap winding, each parallel path will carry a current of IA by P, where IA is the armature current, whereas each parallel path will carry a current of IA by 2. Next is the additional coils. Equalizer rings. Equalizer rings are employed in lap winding is required for obtaining better commutation, whereas in wave winding, dummy coils. Dummy coils are employed in wave winding. These coils to give mechanical balance to the machine. Next is the types. In lap winding, we have three types. One is the simplex lap, second duplex lap, third triplex lap winding. So whereas progressive and retrogressive winding. Other names. So lap winding also called as parallel winding or multiple winding, whereas wave winding is also called as series winding or two circuit winding. Winding cost high, low, EMF less, more, efficiency less, more, average pitch YB minus YF, whereas YB plus YF. Next is the commutator pitch. In lap winding, plus or minus 1. In wave winding, C plus or minus 1 divided by P by 2. So next one is the composite. Lap winding is composed of even number of conductors, whereas in wave winding is composed of that even number which is exactly multiple with 2. So last one is the uses or application. In lap winding, low voltage, high current machines and also welding generator, whereas in wave winding, in high voltage, low current machines. Lap winding are generally used for machines of ratings of above 500 kV, whereas wave windings are generally used for machines of ratings below 500 kW. Next we will see some important objective bits. First one is the purpose of providing dummy coils in a generator is A. To enhance the flux density, B. To amplify voltage, C. To provide mechanical balance, D. To reduce eddy current loss. The answer is C. To provide mechanical balance. Next is equalizer rings are required in case armature is A. Wave winding, B. Lap wound, C. Delta wound, D. Duplex wound. The answer is B. Lap wound. For next one is for generating large currents on DC generators, which winding is generally preferred? A. Progressive wave winding, B. Lap winding, C. Wave winding, D. Current depends on design. Explanation is in lap winding number of paths are more, so we use it for high current and low voltage purpose, and in wave winding number of parallel paths are only 2, hence we use it for high voltage and low current. Example is DC machine having 6 pole with lap winding. In lap winding, A is equal to P, means number of parallel path is 6. So the current flows in 6 armature conductors, whereas in case of wave winding, number of parallel paths is equal to 2. So the current flows in only 2 armature conductor. So that answer is B, lap winding. Next is the commutator pitch for simplex lap winding A. A plus 1, B minus 1, C plus 1 or minus 1, D average pitch. The answer is C plus 1 or minus 1. Next one, resultant pitch in the lap winding is A depends on YB value, B depends on YF value, C depends on YB and YF value, D always equal to 2. The answer is D, always equal to 2. Next question is, what is the relation between conductor current and armature current in wave winding? A, IC is equal to IA, B, IC is equal to 2IA, C, IC is equal to 4IA, D, IC is equal to IA by 2. The answer is D, IC is equal to IA by 2. Next is, wave winding machines are used in dash current applications. A, high, B, moderate, C, low, D can be used anywhere. The answer is C, low current applications. Next is, which of the following windings are necessary in case of all DC machines? A, closed winding, B, lap winding, C, wave winding, D, open type winding. Explanation is, in case of all DC machine, we must use closed winding. Lap and wave windings are used based on the requirement of voltage and current levels. So answer is A, closed winding. Next is, number of armature parallel paths in a 2-pole DC generator having duplex lap winding. A, 2, B, 4, C, 6, D, 8. Explanation is, A is equal to N into number of poles. Here N is equal to 1 for single layer, N is equal to 2 for duplex, N is equal to 3 for triplex. So the answer is 2 into 2, 4. Hence answer is B. So next is, a triplex wave winding will have dash parallel path. A, 2, B, 4, C, 6, D, 8. This question is for you, so kindly answer me in comment section. Thank you for watching. Please like, share to your friends, subscribe my channel and press the bell icon. Then you will not miss my video notification.